So, hello everybody. Last time we looked into addition, subtraction, and we've seen how it could get tricky when we're adding different types like a string and a number and a boolean, string and an array, or using null and defined and more. So today we're going to look into multiplication and we're going to look into division as well, and let's see if there are any similar to addition and subtraction. First of all, I'm gonna refactor this code and change this to 5, and then change this to 9, change this to times, so now z is equal to x times y, and you probably guessed the answer right away before running. This is gonna be 45. Pretty easy, the trivial example that we have every single time. So a question here might be, do we still have the shorthands like x times equal to 5? Do we steal that, which is still the same as x is equal to x times 5? So let's try and see, but first let me print x now instead of z, because we don't have z anymore. So, 25. That works, and we still can do this. But can we do x times times? Is that even a thing? Oh, it's not, because whenever we did this in addition and subtraction, it was possible because we're incrementing or decrementing 1, but here, can we just multiply by 1? We'll still get the same answer, so that's not even a thing to do, so that's why we don't have an operator like that. The same with division. If you divide by 1, you still get, the same number. So let's remove this and get back z. Let's create z again and say x times y. So we can multiply by floating points. So let's multiply 5.2 times 9.2 or 9 first. Let me multiply a float with an integer and see if we get the correct answer. So I'm gonna right now run this and see. Oh, we get 46.8, but whoa, so the you expected 46.8, right? But what is 46.8 0 0 0 0 multiple zeros and then 4? What is that? That could create a problem, and you probably might be asking, could that create a problem? Let's say if I'm testing, if I made an operation on z and now we have that number 46.800, and I'm expecting it to be 46.8. So I'm going to test if z is equal to 46.8, which is what we're expecting, right? And then I'm going to do a console log and say z is equal to 46.8. That's the correct answer. And let me do an else statement and say console.log again, z is not equal to 46.8. And you probably think, okay, we're gonna get true. You're like, this is gonna resolve to true because it's 46.8. So let me see here. Oh, we get z not equal to 46.8. What's going on? That's 46.8. Okay, but look, this very big number here, which does not make sense, is causing the problem because instead of 46.8, we have 0 0 0 0 0 and then 4, which is causing the issue. So how do we fix that? This is a bug in JavaScript when dealing with floating points, and that's a crazy part here that gonna cause issues if you're not aware of that issue. So how to fix that? It's pretty easy actually. You cast this into parentheses like that, and we can use a dot operator if on a number, and then we can use a method called dot fixed, and it takes here a parameter 2, which means whatever the number that comes out of this operation x times y, I want this to be fixed to only 2 decimal points. And if I try this now, oh, we got z is equal to 46.8, and z now becomes 46.8. It is as you've seen, or we can even cast it here into a just 1 decimal point because we don't need the 0, but it still works fine because we this way we removed the 4 at the end, which was causing the issue. And if you see, still get z is equal to 46.8. Okay, so that's the issue with floating points in JavaScript. It's kind of a bug, but still we have a workaround here. You see, using the toFixed method, that we can use on numbers, as we see. All right, so we also can use strings, and you can think about like having a number. Let's say first a text, and let's say another text. I'm gonna try to multiply a string by string. Let's remove the dot fixed. We're not dealing with floating points anymore. Now let's see if that, and let me remove the if statement. We don't need that anymore. Let me put a semicolon and try to run this. And what do you think will happen? Would we get the same behavior as the addition, or would we get whenever concatenation or something like that, or would we get not a number, just as subtraction? So let's see. We got not a number. Okay, this is very similar to what happened during subtraction, because we can't just construct strings out of multiplication. It does not make sense. That's why JavaScript treats, if you're trying to multiply a text by a text, it would just give you not a number. It means that that's not an arithmetic operation that you can do. So let me change this to a number, but inside of a string, but try to multiply this with a number. And let's see what we get. Oh, 45, which means JavaScript seen, okay, we have a string. I'm going to try, and we're trying to multiply a string by a number. So I'm going to try to change that string into a number and see if that's possible. And yeah, I found that, oh, we have 9 as string. So let's change this, or cast this into a number, and cast it into, and change it into 9. And now we're multiplying 9 by 5. That's why we get 45. So it's very similar to what we had in subtraction. Okay, so we still can use null. And if we multiply 9 by null, we get 0, because null is treated as 0, and anything multiplied by 0 will get you 0. We still can use true, and if we do that, we get 9, because true is treated as 1, and anything multiplied by 1 will give you 1. So that's multiplication, and it's pretty similar to subtraction, but we had only this issue with floating points, and I've explained how you can solve this using the dot fixed method that rounds to how many decimal points you're giving into the parameter that this function provides. We just had a look onto multiplication, and now we're going to talk about division. So let me refactor this code a little bit, and instead of 9 here, we're going to put a 8. Instead of true, we're going to have 2, and then instead of multiplication, we're going to have division. And you probably guessed the answer right away. Of course, 8 divided by 2 is 4, very straightforward. We also can divide by a string if it could be casted to a number. So I changed 2 into a string that holds a number 2. Now it works the same as multiplication. You cannot just construct strings out of numbers, out of a division, and that's why whenever we use a divided by 2 as a string, it tries to cast 2 into a number so we can have a value. But if I try to divide, for example, by a text that is not a number, we get not a number, because it works the same. We still have the issue with floating points. So if I change this to, for example, 2.8 divided by, or 8.5 divided by 2.8, let's see what we get. We get a very weird number, and that could cause issues whenever we try to use the if statement, and that's why we could use the toFixed method that we've seen wherever we talked about multiplication. Also, we have an interesting fact here that JavaScript handles, or a case that JavaScript handles. In other languages, whenever you divide by 0, you probably get a runtime error right away, but here, if we divide by 0, we get infinity, which is a representation of the largest number ever in the world, which is infinity, which means it does not end. So JavaScript has a representation for that. That's why whenever you divide by a very small number, very close to zero, that's why you get infinity. In other languages, you probably see errors, but here, or runtime errors, but here we have representation of that, so we don't get an error. Similar, if we divide by infinite or infinity, we get zero because very big number. You divide by a very big number, you get very close to zero. And that's why infinity is the very largest number. You divide by that, you get zero. So that's pretty much it for division. It's pretty similar to a multiplication in terms of how it works in JavaScript, but there's still one thing that I want to talk about, which is a remainder. So let me change x to 20 and change this to 3. Okay, and now instead I'm gonna change this to y again, and I'm gonna change this to the percentage sign. And a percent sign here in computer science just tries to find the remainder of this operation whenever we divide x divide x by y. So we're trying to divide 20 by 3. So what do we get? We probably get a decimal. And how it works is the remainder is how many 3's fits into a 20. And if you think about it, 3 fits 6 times into a 20, means 3 times 6, you get 18, and you can't fit any more 3's into 20, because if you fit another 3, you'll get 21, and now it does not fit. So you get 18, and to reach 20, you guessed it, it's going to be 20 minus 18, and that's why we get 2. So we get 18, and the remainder till 20 is 2. So that's how remainders work, pretty easy. And this is how division works, and we talked about multiplication as well. They're pretty similar to subtraction in terms of how they handle strings whenever you try to multiply or divide by string. Addition is the exception here. We have the concatenation and so on. So you're gonna get the hang of it. Once you have to try a lot, and you're gonna get good at this, hopefully. So I'll see you next video.